sound right, boys. Sound right, boy. It sound right, boy.
Boa noite, galera. Bem-vindos, bem-vindas todas a mais um Zup Open Talks para falar de um assunto maravilhoso com uma pessoa maravilhosa hoje. Recadinhos básicos de toda semana para quem não conhece nossos projetos Open Source, que tem tudo a ver com o que a gente vai conversar aqui hoje. opensource.zup.com.br, vocês encontram tudo sobre os nossos projetos lá, temos fórum, temos um canal de Discord, no Discord agora para a gente bater papo com a comunidade. E tá tudo no portal, nos nossos fóruns. É só marcar a gente em rede social se tiver dúvida, sugestão e quiser bater papo sobre os projetos. Quer trabalhar numa empresa que se preocupa de verdade com o teu desenvolvimento que vai colocar o Brasil no mapa mundo da tecnologia, que acredita que a gente só desenvolve tecnologia de ponta, com gente de ponta, motivada, engajada e sempre se preocupando em aprender, estudar e se ajudar, vem para a Zup. Temos diversas vagas. A galera vai deixar aí na descrição também os links para as vagas. Então, vem trabalhar com a gente, vamos junto colocar o Brasil no mapa mundo do software. E eu realmente estou esperando há 17 anos para gravar esse papo. Faz 17 anos que eu conheço o Jon Hall, faz 17 anos que a gente se encontra em eventos. Eu vou tentar fazer um resumo com ele hoje da história do Linux, porque eu conheço muito detalhe que ele já me contou. Então, vou convidar no palco. Vou fazer a minha autodescrição em inglês também, porque vai ter muita gente vindo de fora. So, I am a white man with a beard more whiter than I would like it to be. I'm with a small ponytail. My background is blue with an LED light. I'm wearing a black t-shirt. And I would like to invite right now to stage my good friend, Jon Hall. Please, Jon, welcome.
Well, thank you very much, Jomar. It's nice to be here. Before we get started, I do want to make one correction. I saw something come across my screen that said, "Bye to Linux." And that's father of Linux, I believe. I'm not the father of Linux. That is Linus Torvalds. I am the godfather of Linux.
That's perfect. And talking about father, you are also known in Brazil by other name, right?
Yes, Papai Noel. Yes. And I wear that with great pride. You can see that I'm growing my beard out now. It's getting longer. And that, about December the 15th or so, little children start looking at me funny. So, but then on December the 26th, I cut my beard quite a bit shorter, and Papai Noel goes back to the North Pole.
And Joe goes back to the computers.
Yes.
So, my friend, we have a lot of things to talk today, but one thing that I really would like you to share with us is, when did you decided to start working with computers, and how the technology world was at that time?
Well, I was studying in high school, actually, electronics class. And I would make radios and TVs, which were analog at the time, not digital. I would make them out of resistors and capacitors and coils and things like that. I decided I wanted to be an electrical engineer. So I went to university to study electrical engineering. And then one day, I had a co-op job, cooperative education. And I went to a company named Western Electric. And they offered me a correspondence course. By reading a book and punching paper cards, I could learn the language Fortran. They had a computer there that you programmed with Fortran. It was so simple and so small, logically speaking, that it didn't even have an operating system. You linked the device drivers into your program, not into the operating system. And then you booted, in effect, your program to run on the system, one at a time. So there was lots of switches that you could turn up and down to control your program, because there was only one program in the entire system running. And this fascinated me. To me, it was the simplest type of math. It was pure logic. And I would see the results of that logic immediately. So I became very interested in programming these wonderful things called computers. Now, back in those days, there were no computers in the home. There were no computers. There weren't that many computers in business, actually. And so this was the first time I'd ever seen a computer in real life. And over the years, I did less and less electrical engineering and more programming, until finally programming became, in effect, my major. I did have a professor who told me that I would never be able to make a living as a professional programmer. And that was because back in those days, there weren't that many professional programmers. The people that wrote programs were physicists and electrical engineers and business people, and they wrote the programs for their own use, not for other people. When they got finished with the programs, they would look around and say, well, what am I going to do with this? Because selling software is actually hard work, and that was not what they were doing. So they would contribute their software to organizations like DECUS and Share, user organizations. And these organizations would then contribute or distribute the software to other people who needed it or wanted it, basically for the cost of distribution. So a text editor, for example, might cost you $5 and you would receive it on paper tape to put into your computer system. An assembler was a longer piece of code. It might cost you $15 because the more paper tape, more time to punch it, things like that. But at the same time, it was a lot cheaper than commercial software, which was available, because you might pay $100,000 for one copy of a compiler to be used by one person on one machine. And that was $100,000 in 1969.
Yeah, a lot of money.
Yes.
Yes. So, and John, when after this beginning as a programmer, you started working on computer companies, and then you ended up working on digital, right?
Well, actually, I didn't go to work for a computer company in the beginning. I went to work for an insurance company. And like I said, the insurance company needed programming to solve their problems. So they had a lot of computers. In fact, it turns out that just by accident, just by luck, I worked for the largest commercial user of IBM equipment in the free world. Um, we didn't know what the Chinese and the Russians were doing, so that's the free world part. We didn't know what the military or the government was doing, so that was the commercial part. But Aetna was the largest user of IBM equipment in commerce. And we had 500,000 magnetic tapes in our tape library on site, with another 100,000 magnetic tapes in a salt mine in a state in Idaho. So we automatically ordered two of everything that IBM announced. So when a company is going to make a new computer system or a new disk drive, they make an announcement. And then sometimes later, a salesman might show up and say, do you want to buy this? No, we didn't do that. When IBM announced it, Aetna automatically ordered two. And one of them went to our research center to find out how we were going to use it. And the other one went to our computing floor because we knew that sooner or later we would be able to use it. Didn't make any difference how much it cost. And I'll remind people that back in those days, a 180 megabyte drive would cost 32,000 US dollars in 1969.
Yeah, and it was amazing to have one of those.
One, we had 500 of them hooked up to one
Amazing.
file on one system in one building.
So, and when you first heard about the work Linus was doing with the kernel?
I was working for Digital Equipment Corporation in their Unix group. From the time I left Aetna, I had taught for 3 years in a university situation. Then I went to work for Bell Laboratories and I learned Unix. And then I did that for 3 years. And then I went to Digital Equipment Corporation because they were starting up their own Unix group. to make their own version of Unix based on Berkeley 4.1c. So, we were doing fine and everything. We had just come out with the Alpha processor. It was a 64-bit processor. And we had VMS on it. That was our proprietary operating system. And we had digital Unix on it. But what I wanted was some operating system that the source code was available so that people could do research in very large address spaces. And there was BSD that was out there, but they were still going through a big lawsuit with the USL, and we didn't know how the lawsuit was going to turn out. The source code license for AT&T Unix or any Unix was $160,000 per CPU. And I knew that that was not good for people that wanted to do research. So I was going to one of these events, DECUS, this user event I told you about before. It was down in New Orleans. And a friend of mine was trying to get this person to come from Europe to this conference to talk about this project they had never heard of. And he was having trouble raising the money for this. So I went to my management and said, I think we should fund this. And we had $5,000 to fund this person from Europe to come to this conference. And then my friend asked me something that was horrible. He said he wanted an Intel PC to run this software on. And I tried to tell my friend that I was not responsible for Intel PCs at DEC. I had real computer systems. I had VAXs. I had MIPS systems. I had Alpha systems. Not one of those weak, miserable, crappy, stupid Intel systems. But he was very insistent, so I got him some money to get a system for him. And then I flew down to New Orleans to, attend a conference. And I found my friend, and he was trying to install this software on the PC, not being very successful, when this nice young man with sandy brown hair, wire rimmed glasses, sandals, and socks came up and said with a very lilting European accent, "Can I help you?" And my friend looked at him and smiled and said, "Yes, I think you can." And about 10 minutes later, Linux was working on that PC. And they invited me to sit down and use it. Now, I collect pianos, automated musical instruments, player pianos, pianolas, uh, Nickelodeons, automated reed organs. I collect them. And of course, all of these are keyboards. But I don't play any keyboards. I only play the computer keyboard. But as I sat down and tried this system out, it was very responsive. It was very, fast for being on this weak, miserable, crappy Intel PC. and I went, and if I thought of it like System 5, that was one version of Unix, if I thought of it that way, it seemed like it was System 5. And if I thought of it as Berkeley, it seemed like it was Berkeley. And I said, this is very good. This is amazing on this weak, miserable, crappy Intel PC. So I then went to his talks. He gave 2 talks. About 40 people came to each one of the talks. We had 19,000 people at DECUS, and only 40 people came to listen to this college student from Helsinki, Finland. And I'm sure that afterwards, when they realized who he was and what he had done and what GNU Linux was going to be, that many of those people just kicked themselves for not going there and listening to him. So after the talks were over, after DECUS was over, I took this nice young man out on this riverboat. We went up and down the Mississippi River on the last steamboat that was on the Mississippi River. Now, I found out later that Linus really likes steam engines. He likes Stirling engines. Uh, he likes clocks and watches, and these are all things that I like, but I didn't know it at the time. So I took him to the back of the boat. I showed him how it worked and everything, and he was very impressed. And we had dinner, and then we had these wonderful drinks called hurricanes. And the reason they're called hurricanes is because you have two of them and you feel like you've been hit by Katrina. Okay. And we're up there, we're in the front of the boat, we're drinking these hurricanes. And I said, Linus, have you ever thought about porting Linux to a 64-bit processor and a RISC processor and making the kernel more portable, more transparent? And he says, well, yes, I have thought about that. But it's been very hard for the people in Helsinki, the DEC people in Helsinki, to get me an alpha system. And so I may have to do the IBM Power PC instead. And I knew that was the wrong answer, right? In my heart of hearts, I knew they should be porting to the DEC Alpha because for 8 years, the Alpha was the fastest microprocessor in the world. We were in the Guinness Book of Records as being the fastest. Plus, I needed that operating system so that my researchers can look to see what happens when you have 64 bits of memory. Now, a lot of people don't really realize how big 64 bits is. If you have 32 bits, it means that you can store 4 billion bytes of data. But if you have 64 bits, you can store 4 billion times 4 billion bytes of data. So how much is that? You could store a gigabyte of data on a disk every day, every second of every day for the next 584 years and still not run out of address space. So it's huge, very huge. And where there are certain problems that you really need that type of address space. Global warming is an example of it. Most of these problems come with the term fluid dynamics. Okay. And everything is fluid dynamics. Even if it's a solid, it's still fluid dynamics. As the heat passes through the solid, that's fluid dynamics. Airplanes fly because of fluid dynamics. Cars go down the road and stop because of fluid dynamics. And so you need something that can handle that type of data. And I said, I think that Linux can do it. So I went back to my office and I called up a friend of mine and I said, you don't know who this guy is and you don't know what he did. And I don't have the time to tell you. You need to send an alpha system to Helsinki, Finland right away, like tomorrow. Now, back in those days, they didn't have that many alphas around. A lot of the engineers in my group would have to go out of the lab and share an alpha to do their work. They would have to wear a coat because it was cold and earmuffs because it was noisy. And what I was asking this man to do was, on my word alone, send this machine to Helsinki, Finland, to this person he'd never heard of. And it wasn't just, and oh, by the way, these machines were not a $400 laptop or a $1,000 desktop.
Very expensive.
30,000 US dollars in 1994. And what did you get for that? You got 96 megabytes of main memory. You got a 4 gigabyte hard disk drive. You got a 21-inch color monitor, very heavy. You got a diamond graphics card. You got a keyboard and a mouse. But what was missing was in a 4X CD-ROM. But what was missing was a backup device. The CD-ROM was read-only. He needed a backup device, and so I said, throw in a 4 millimeter tape drive. That was worth $6,000 alone, and you have a deal. And my friend
Wow.
was laughing by this point. He was laughing. He said, "What are you going to pay for?" I said, "I'll pay for the shipping." And so the next day, there was a system heading to Helsinki, Finland.
And then Linus started porting for Alpha, right?
Not right away. What happened was he had just put out version 1.0 of the kernel right before Deakus. And what he wanted to do was to fix or make the bugs fixed so it was stable. And he wanted to bring out like version 1.2 before he started in with the actual port. But in the meantime, what I was doing was sending him electronic documentation on the alpha instruction set, on the board, and things like that. And I was also finding some engineers inside of DEC who could help with the low level portions of the port, and including a very good friend of mine, David Rustling, who was working for the Digital Semiconductor Group. That group had done a study because they saw the same thing. They wanted some operating systems to go onto the alpha that would stimulate interest in it. And they had actually looked at BSD, they had looked at SCO, they had looked at CPM, they had looked at a variety of different systems, and independent from me, without any of my input, they also had selected Linux. But they were interested in a 32-bit port, not a 64-bit port. And I said, no, you have to do 64 bits because that's at least half the value of the alpha. And they said, well, the problem is that all the software would have to be ported to that 64 bits. You know, all the GNU software, everything would have to be ported. I says, no, the GNU software already works on top of digital Unix that was 64-bit. So there's no porting of the upper level pieces of code. It's already been ported. And they didn't believe me. So they did a little test. They found out that I was correct. And so they scrapped their project and started in helping with the 64-bit port. And my friend, David Rustling, he had never even thought about coding for open source up until that time. But he was the person who wrote the Milo bootloader for the alpha, which was like
Whoa.
Lilo, but Milo.
Okay. And while this movement was happening with Linux and the developers, how the business people on digital start looking at this? Because it's something like, it may sound weird, you know. We give a machine to a student, and we have a bunch of researchers, and they're coming out with this new thing. So how was the value or the business value that they were seeing on that?
Well, first of all, let me tell you about the engineers. Pardon me. I came back from Deakus. I was all excited about this. And the engineer said to me, oh, it's great you found out about this. We've been using it for 6 months. I said, what? Oh, pardon me. They said, yes. You see, we didn't have digital Unix on laptops. We only had it on desktop systems and Surface systems. So when they wanted to do their own code, when they wanted to do code for digital Unix, they would first get it to work on Linux, and then they would take it back to digital and recompile it for for alpha and for the VAX. So they were already using Linux on their laptops, and they said, hey, best idea is sliced bread of having Linux on the alpha. So that was the engineers. The product managers had a slightly different view of this. They said, what in God's name is MadDog doing? You know, it's a free operating system. And to be truthful, let's take a look between Linux at that time, Linux version 1.0 or even 1.2, and digital Unix. Linux was single CPU, single threaded. Digital Unix was multi-threaded SMP. Uh, you know, Linux still had some pretty fragile file systems. We had some more ruggedized file systems, log-based file systems. There was lots of different comparisons. But the one thing that Linux was, that digital Unix was not, was it was free software. It was the freedom that you could change the software, put on as many systems as you wanted to. You didn't have to worry about the licensing. That was the difference. And I proved to my management that I could actually sell more digital Unix with Linux than without. Because people would hear about the Linux system and being pointed to the alpha, and they would say, "Oh, that's kind of neat. I'd like to try that out." And the digital salesman would get them an alpha to try it out with Linux, and they would try it out. And they said, "Wow, that's nice, but I need all these other features that only exist in digital Unix." And the salesman would say, "Well, you already have the alpha. Let me get you a copy of digital Unix." And they would do, and they say, and I have letters where I sold 3,000 server systems to Mindspring in Georgia because of Alpha Linux. And I have look at what happened with Beowulf Systems. In 1995, Beowulf Systems came in. That was just the time that the Alpha Linux port was being done. Here's the concept that you're going to take a supercomputer and replace it with commodity software. So we had a whole line of business set up to put Alpha systems in racks and put the Beowulf software on there and sell 64-bit supercomputers. We sold billions of dollars of them. And people say, well, you could have done the same thing with digital Unix. That is true. However, the people liked Linux and they liked the freedom they had, particularly in the supercomputer space. You don't go down to your local PC store and get your supercomputer application off the shelf or in the box. Doesn't happen. You write it yourself, you get it to work, and it's unique. So it was a good thing.
Yeah, and at that time, John, did you envision it that Linux will be omnipresent nowadays?
It was hard to look forward that much because I didn't know exactly where the community was going. It's interesting that a lot of people say, "Oh, what Linus wanted was a free operating system, as in free of cost." No, he didn't want that, actually. He was happy to be able to sell it, but he realized that if he tried to do that, he would be right up against Hewlett Packard and digital and things, and he wouldn't be able to get the people to work on it that he needed. And so the GNU license was almost an afterthought of Linus to make it free. And so, but what they wanted, Linus, people like David Miller and Alan Cox, and a lot of the people who started the project, what they really wanted was a good operating system. They wanted something that was efficient, that was relatively small, that was very portable across all these platforms, that had a good TCP/IP stack, and so it was, but as time went on, I started to be able to understand this issue. And, I can point to the times. So Beowulf systems were 1995. Um, Embedded systems was about the year 2000. Now, why did that happen? Well, up until 2000, there was a lot of companies like Wind River and other companies that had their own operating system that they wrote, and they would use that, and they would put it on a processor that they were used to and things. But around the time, and the only way you talked to these embedded systems was through a keyboard and a screen or serial line or things like that. But then in the year 2000, something else happened that people started to say, I want to have these systems on the internet. And now you needed to have a good TCP/IP stack, and that is not easy to do. And you also needed to have good security, because as soon as you put your thing on the internet, there's going to be somebody trying to break in. And another thing that happened was people said, well, we want to have different processors. We don't want to have just Intel. We want to have ARM. We want to have Motorola. And so these companies were being required to port their systems to these different processors. And it also means different compilers. And they said, no, we can't do this. We need to have something that is secure, flexible, portable, and has a good TCP/IP stack and is free. And that was basically Linux. Now, by that time, the suit against BSD was over with. BSD Lite was out. And some of those people chose BSD as the basis of their embedded systems. But a lot of people chose Linux. And so about the only place that we haven't made that type of innovation or that type of penetration is on the desktop. And I know that is a sore subject with people. And because every year is the year of the Linux desktop. But if you really think about it, there's been, first of all, why has that happened? Why did that happen? Well, up until that time, Microsoft had about 90% of the desktop market. Apple had about 7%. And Linux and other things had about 3%. But, and so because of that 90% penetration, people would run their Windows systems with a paper notebook. They would say, oh, I'm going to log in. So they would write down login on their paper, and they would type in their login name, and they would write out their password. They would follow that step by step by step to do whatever they were going to do. That was how they ran it. But then all of a sudden, you had these things called browsers come in. And the browsers kept changing. Every time you executed it was different. And it had all these things called scroll bars and button boxes and things. And they all changed in a fraction of a second. It wasn't like another release was coming out. All of it, you tried to use it, and everything was different. So people couldn't do that anymore. And you not only had one browser called Internet Explorer, but you had other browsers called Firefox, and you had browsers, called Chromium, and you had and so they had to understand what was going on inside the system. They had to understand that it could look slightly different, but it's a scroll bar. It could look slightly different, but it's a button box.
Internet right now.
So that's what's going on.
And try again.
And people got used to that. So that changed things. And then the other things that changed it were things like Chromebooks and the web and things. So the lock-in by user interface was gone. So that was one thing that happened, and more Linux systems started to grow up. The other thing that happened was that there were more and more computers on the low end, or used computers, that were available to people from low incomes. These people couldn't really afford to buy all the proprietary software that was out there. Now, this has a problem, and particularly in countries that do not have a very high gross domestic product. A lot of these countries pirate their own software. I know that Richard Stallman hates that word, pirate, but nevertheless, we'll use that term. They pirate their software. And for example, when I first started going to Brazil, you pirated 84% of your desktop software. China pirated 92% of the desktop software. Now, because of the World Trade Organization, they are at around 84%. Vietnam pirated 96% of their software, and they still pirate quite a bit. And it's because it's hugely expensive, this desktop software. And if you're told on one hand that you have to be on the internet, you have to use computers to do business, but on the other hand, it takes you 2 months worth of salary to buy an office package. Well, quite frankly, I would slap a patch on my eye and go, RRR, matey, right? So I'm very sympathetic to this. Nevertheless, this hurts free software. Because I would go to Brazil and I would say, you should be using free software. And they would say, oh, MadDog, all of our software is free. And they don't realize that this attitude takes away money from them as programmers, from them as people in the computer industry. And that what they should be doing is encouraging their friends to use software that has a different business model, a business model based on charging people for what they're going to be getting out of it and for the benefit of their business in using it. So these are things that I started to see as we talked about, the desktop. And today, if you take a look at it, Android is outselling iOS on phones. The Chromium and Chromebooks are making huge introductions going into the desktop marketplace. And so Linux, whatever you want to call it, is becoming more and more prevalent on the desktop. And I think that Microsoft sees this. What they're doing is they're moving to more of a server web-based business so that they force people to pay a lower price. I mean, there's a good thing about that. You don't pay as much for Office 360 as you paid for Microsoft Office on your desktop. It's easier for them to do. But these people are going to be forced to pay that money, and they're still not going to be able to change the software to do what they need. And so we also have to get people to stop thinking about total cost of ownership, because in reality, the total cost of ownership of free software is about the total cost of ownership of proprietary software for the first 5 years. They only talk about the first 5 years. And then on the 6th year, there is a step function that happens with proprietary software when you go to create new licenses. With free software, it still continues along the same slope. So, in fact, after you've got the software working and things like that, you pay very, very little in total cost of ownership for free software. However, that's not the most important part. The most important part is return on investment, ROI. What does the software do for you? How much can you get out of the software? How can you improve your business? That is where free software shines. And once you start using it and get used to it, you find out that you can change the software to meet your business needs. Maybe you don't have the ability to change the software yourself, but at least you have the choice of doing that. You have the choice of changing the software. And maybe you can hire somebody to change the software for you. Or if you have a business association, maybe you can get the people in the business association to all contribute money to change the software the way you want to. And now you have the software doing what you need it to do, and Does everybody else benefit from it too? Yes. But what do you care? Okay. You got it to do what you needed to do. You got your return on your investment.
Yeah, amazing. And about the desktop idea on Linux is something that I used to talk with friends here. The thing is, it doesn't matter for me if it's the year of Linux on desktop, because actually we don't use desktops anymore. So I got tablets, I have smartphones, smart TVs, smart watches, smart stuff that we used to do and use the desktop in the past. So it's omnipresent. Wherever I look in this room, where I am, I can see there are Linux servers running here on my lights. Here in my background, there is a Linux board. So I think the way you helped the industry sees the value for Linux, Jon, was something amazing. And talking about amazing stuff you did, when did you start coming to Brazil, and why you like so much come to Brazil and help Brazilians as myself to grow on free software?
Well, first of all, it's not just Brazil. The first time I came to South America was to Caracas, Venezuela. We had a DECUS meeting there, and it exposed me for the first time to people and things like that in Latin America. Um, this was pre Chavez, so the economy of Venezuela was still very good. And I went down there and I really liked the people. So I came back, and then in 1996, I went down to Brazil for the first time, and I went to Sao Paulo and saw the University of Sao Paulo. Now this is embarrassing for me, for my country, but I will tell you that most of the people in the United States, when they think of Brazil, they think of carnival, they think of soccer, or football. They think of piranha in the Amazon. They think of the rainforest, but they have no idea. They never think about the fact that Sao Paulo is the largest city in the Western Hemisphere, way bigger than Los Angeles or New York. And they don't think about that. They don't think about the tall buildings that you have. They don't think about the fact that the University of Sao Paulo has 100,000 students and 16,000 PhDs. And if you have a problem that you can't find somebody at the University of Sao Paulo that has spent their whole life worrying about something, then you haven't done your job. So I saw the first Beowulf supercomputer I ever physically saw there at the university. I then I saw, and they were doing amazing things with it, incredible things. Um, I got to see some of the other things they were doing with Linux. And remember, this is 1996, right? It's just 2 years after the Alpha port was started, and I was pretty blown away. So then I started making friends. I met friends at the For Linux company, uh, Marcelo Marquez and Adolfo Gobi. Made friends with them. You had a version of the Linux magazine down there, Rafael da Silva. I
Yeah.
made friends with them, and I started making friends with lots of people. And I was invited to conferences. I was invited to Feastly. I was invited to Latino Wear, the first Latino Wear, and people were very welcoming. But what I liked about the people was I would go to companies like Opens, which is in San Jose, in Santa Catarina. I would go there, and the people would be working and working and working, and then time for lunch, they would all grab their guitars and sing and stuff like that, have a good time. End of the day come, let's go to have a barbecue, bring the guitars and sing and stuff. And it was this mixture of work and pleasure and friendship that really inspired me. And I really like that. I realize that Brazil has its own issues, its own things that needs to be done. But I believe also that it has a huge potential. And, you know, I would like to see it take its place. It's, I think, the fifth largest country in the world in population. And it has a land area with huge natural resources that need to be managed. But, you know, I see a problem in the fact that a lot of universities give free, tuition free education. But after a couple years, a lot of those people want to leave Brazil and go to the United States or go to Europe or go to China because that's where the good jobs are. And free software allows those good jobs to be in Brazil. You know, why are you spending all of this money sending it to Microsoft, sending it to Oracle, sending it to these different companies when you could have keep that in Brazil and pay young programmers to work on great projects to tailor the software exactly to your needs? And that means that you now have local money for those young programmers to buy local food, local housing, and pay local taxes. The money keeps circulating inside of Brazil, inside of Latin America. I went to Colombia one time for a campus party. I saw students there, high school students, working on Internet of Things at the beginning of the Internet of Things program. They were creating models that they could open garage doors and turn on lights and stuff in their little model houses using Arduinos and the beginnings of the Raspberry Pi. One of those campus party students doing this at the age of 17, now, several years later, has his own company producing these components. I have friends of mine, really, tremendous people in Brazil that do amazing things. And it irritates me that these people feel that they have to leave Brazil to get a good job. So that's why I keep working in Brazil,
So,
working on projects I hope will get a spark going and turn this around.
yeah, John, and thank you so much because you motivated a lot of people here
Thank you.
with all those things. We are seeing people commenting on the chat here. I'm seeing, by the way, very lots of no names and faces here with us, and I think that I used to tell people that I'm a very lucky person in the world because the first time I asked it for someone the good and old stupid silly questions about open source, it was for you on an event in São Paulo 17 years ago. And you were so kind, you were so open, you were so truth, and you treat me with so much respect. At the time, as a young guy that thought that I need a coat, and short hair to be taken serious. And when I think you showed us not only the value about open source and free software and all those things, but you are a role sample for us here.
Thank you.
And thank you so much for that. Talking about a little bit the future, John, what do you think is the next big challenge for Linux over the next years? Because Linux is basically the base of the cloud technologies we have today. Linux is the base of our autonomous driving cars and things like that. So what do you think are the next challenges for Linux over the next years?
Well, I could speak about this in a couple different ways. I could say, what are the opportunities for Linux and free software? And one opportunity that I see is better use of field programmable gate arrays. Pardon me. Field programmable gate arrays, FPGAs, and that you can program those kind of like tiny little programs. So your CPU is made up of these things called gates, transistors, and they are programmed in a certain way by putting them onto a piece of silicon. They do one particular thing. A field programmable gate array can be programmed to move those gates around and therefore do multiple things, but very quickly, maybe 100 times faster than a regular CPU. And you can use these field programmable gate arrays to accelerate things that a CPU would normally do. So, what are examples of this? A GPU, graphical processing unit, is in effect a CPU that's been built a different way. And you allow it instructions that takes those instructions and treats big pieces of data in parallel. You could program an FPGA to do that. So instead of having to buy
I believe we have an issue with his connection.
We're back.
Okay, great.
So you can buy a GPU, but that's all the GPU does. It does graphical things, and today it's doing things that are oriented towards AI. Or you could program an FPGA to do what the GPU does. But then in the next moment, you could say, well, I don't need the GPU anymore. What I want to do now is mine Bitcoin. And so you can program the FPGA to mine Bitcoin. Now, people have programmed the GPU to mine Bitcoin, but there's a lot of overhead there. It's not very efficient. You can program the FPGA to be very efficient. The next step that you may have heard of is called an ASIC, ASIC. That is a fixed orientation of the transistors. Just like the GPU is a fixed orientation of the transistors, and the CPU is a fixed orientation of transistors. There's a pattern here. The FPGA could be programmed to be a CPU, it could be programmed to be a GPU, and it could be programmed to be an ASIC. It may be slightly slower than if you tried to put that directly into the silicon, but it still is many times faster than if you try to use these components to solve all these problems. So I think that people learning to program FPGAs, and particularly a project called Open FPGA, which is making an open tool chain to programming, people be able to program them to do all sorts of things without having to spend lots of money for licenses. Coming back. Okay. I don't know what's going on, but we'll continue.
Yeah. So it's really interesting, this idea of accelerators, because we have much more access to different level of silicon components today.
Okay, I
and
saw
also,
you move.
Yeah. So and
so that's one thing. Intelligence, yes. We're having a little bit of problems here. I don't know where they are, where they're happening.
Yeah. So, Jon, my final one. I hope the internet helps us. Let me just write something here for. Okay. So, can you listen me? I think his connection dropped. Let me try adding him again. Can you listen me, John? Maybe, Ivan. Maybe. I'm not sure if it's his connection. And let me try to reconnect John here. I'm not sure if it's from his side. Let me send him a message.
Are we back?
Oh, we are back, I think.
Okay.
Okay.
For now. So what's your last question?
Yeah, yeah. Now the last one is we are talking about you as the role sample for us all here. And in 2012, you did something that really touched me personally. On the anniversary of 100 years of Alan Turing, you, after your age, after doing everything you did for the industry, you just come out in public and talked about your homosexuality. How hard was that decision? And what happens with the relationship with people after that?
Well, first of all, the reason I didn't come out before was that my family was very conservative, uh, Southern Presbyterian people. My mother actually believed, well, both my mother and father believed that the world was 6,000 years old. They didn't believe in evolution. Um, they were very, very conservative. My brother and sister-in-law were evangelical Christians, and they also, sitting around the dinner table, would voice their uh, uh, feelings about homosexuals and a whole bunch of different people. So I kept my homosexuality to myself. I stayed in the closet. The reason for that, because I didn't want my mother to think, oh, when he dies, he's not going to go to heaven. We're not going to be together. There's this type of stuff. They were old, and I didn't want to have them feel that way. However, about 11 years ago, my mother and father died. They had 69 wonderful years of marriage, and at the same time, we were starting to have issues around marriage equality in New Hampshire, the state I was living in. So I decided to work, you know, to try and get marriage equality in our state and then eventually in the United States. And I started to come out more. I came out to my friends. My friends said, okay. Before this, I had actually come out to two groups of people in Brazil. One of them was Dennis Galvão, who is the father of my first Brazilian godson, and another was Lucas Moselin, who is the father of my second Brazilian godson. And I would say to them, before I say that I will be the godfather of your children, I want you to know that I am gay. And they would say, yeah, so what? You know, these people knew me. They knew me. They knew the type of person I was. They knew that, just because I told them that I was homosexual, that it was not going to make any difference between the way we felt about each other. And so but then in this marriage equality thing, I started seeing the hate that people had against people just because they were gay. I started, I would read newspaper articles and things like that. But more importantly, I saw kids who were 15, 16 years old, even younger, who were coming to terms with the fact that they were not heterosexual, that they were different. And their families were tossing them out of the house. That the suicide rate of young gay people is 4 or 5 times the suicide rate of heterosexual young people. And I realized that this was wrong. And geeky people, kids who wear glasses, kids who like electronics and stuff, they did not in those days. They weren't in the same time frame as they are now. Today, geeky kids are looked at differently, but in those days they were nerds, and they were under a double whammy. They were nerds and they were gay, and this put a double feeling on them. So I wanted to come out. I wanted to say, look, you know, you can be gay. You can have a successful career. You can be liked by other people. Don't give up. Just get through it. Maybe you're in high school. Maybe you have to stay in the closet because of your situation. But you will get out. And when you get out, you'll make your own way. And when you make your own way, you'll be able to meet and stay with the friends that you like, and they will accept you for who you are. And come up to me. I've had people come up to me at campus parties and things like that and say, thank you for saying that. Thank you for writing that article. Thank you for talking about me. One time, right after I wrote the article, I went to a campus party and I was walking along, and this one young man comes up to me, and he's yelling to all of his friends around, he's gay, he's gay, he's gay. And I walked over to him and I said, yes, I am gay. And it's a tiny, tiny little part of my personality. It's a tiny bit of what I do. And the kid looked, and I think I may have, in a moment, changed the way he looks at LGBTQ people. So I don't go on to face, while I do mention this from time to time, some of the things I see, I don't say that I'm a gay person first and I'm everything else later. It's, you get what you get. You get the whole package, right? And it is a tiny but very important part of my being.
Yeah, my friends, thank you so much. I'm sorry, the connection is struggling again.
Back about. Okay. Can you hear me now?
Yeah.
Can you hear me now?
Yeah.
Okay. About 8 years ago, I met somebody and we went together for about 3 years. And then 5 years ago, I married them. And this has been a wonderful situation to have that type of relationship for the first time in my entire life. So it means a lot. So I hope you'll be able to edit this together and take some of these little glitches out of it.
Yeah.
Can you hear me?
Yeah.
All right.
Yeah, can hear you, but the connection is not helping us.
Right. Well, I hope that you'll be able to take and edit some of these glitches out before you put it up on the net. Okay.
Yeah, yeah. I can ask. Actually, it will be automatically published today, but we can find them later. Don't worry. And by the way, we need to have another talk like that. People are sending me notes. Please, Jon Hall Part 2. There's a lot of other things we would like to know from him. And this is it, Jon. Thank you so much. Thank you for being that light for us, and
Well,
keep pushing us to believe that Brazil and free software is something that we really need to believe and invest.
I will. Uh, I will also tell you that in early pitches, although looking at my system metrics, I don't see where the problem is. So, but we
Yeah,
can continue to work on it, and we can certainly do this again.
Of course, and it's probably on the streaming platform. I also reduced the resolution of my camera. I'm going to do this on the next time. So, Jon,
I did
thank
that
you
some
so
time
much.
ago, and it did help with these. Okay.
Yeah, you told me that you would wear your Papai Noel hat, but then I prepared a surprise for you here because it's Halloween. So this is not an ordinary Zup Open Talks. This is one of the best I ever recorded with my good friend, and I will close this one in a very different fashion, like this. Thank you so much, Jon.
Oh.
Happy Halloween.
Yes. Well, I have a similar one.
Yeah.
Halloween, by the way, is one of my favorite holidays. Halloween and the Day of the Dead in Mexico is one of my favorite holidays because I think it's a fun holiday and we get to dress up as whoever we want to be or don't want to be. Okay.
Yeah, amazing. Thank you so much, Jon, for being with us. We're gonna have another one because there's a lot of other things that were on my script that we didn't have time to talk about LPI, about Linux International, and about the Caminos Locos project that you have in Brazil. So we're gonna schedule a new one and continue the conversation. Thank you so much, my friend.
Thank you very much, Lillian, for all of your help. I appreciate it.
Thank you, guys. Good night. Happy
Good night.
Halloween.
Happy
Bye-bye.
Halloween.